Okay, guys. So before we start something new, we're going to have a look at 2c and 2g, was it? So 2c was 8 over x power 4. 8 over x power 4. That's equal to 8 x power minus 4. Charles, focus, please. So what we do is, Tolu as well, and what you're concentrating to, you're looking very distracted. Increase the power by 1. Tolu, sit up the front actually. I'm not quite trusting you right now. You're looking very distracted. Sit up the front there, please. Yeah. And Charles as well. Over that side. Now just get moving now and don't give me any hassle, please. Yeah, increase the power by 1 and then divide by the new power. Charles, you're knocking the cable for the projector. Would you come on? Push. That's right. Hamish, hurry up. Okay. And that's it, something. You can leave the answer like that, or if you want, you can write the answer like this. Huh? Oh, sorry. Thank you. 8 there. Okay. Where are you going? Is that his book? Okay. Sorry, I'm very distracted at the moment. 3 here. Yes? Okay. Now the next one is, which one, Sultan? 2G. Can you just read it out? What is it? 1 over?
That's 2 over E9. E composite.
Like this?
Yeah.
Okay. So what we do for this one is we change this into 2 e power minus 9. Joshua! No, that's fine, but don't lean against the wall, okay? That really annoys me. So face forward fully. No, actually, move 1C over and sit beside Daniel. Yeah. Now don't get too close, okay? He's sick. Alright, but just move 1C over. Try not to breathe in his air, okay? Good. 9x. Now, the rule here, we have this in the formula book. All we have to do is divide by the minus 9. And that's it, finished. That's all. Okay? No, it doesn't. Just the number. And the power doesn't change. A common mistake here would be to change that 9 in the power. Okay, now I didn't really mention this so much in the last class, and soon, I know you were mentioning this as well at the end of the class. I call these integrals, or, well, integration, or integrate is the verb, and integral is the noun. Okay, but if I'm being very specific, I should really call this indefinite integrals. You don't have to worry just yet what that means. So the full and proper name for this will be indefinite integrals. So this is indefinite integrals. And what we're going to look at today now is definite integrals. So now we need to explain the difference between the two. Okay? So what exactly is an indefinite integral and a definite integral? Yes, you're right. It's not quite called a power, but I know what you mean, yes. Has limits, or subscript and superscript. This here is called an indefinite integral, as you don't know, but you know now. But when I put what you said there, Tanish, the word, what are these called? Limits. These are called limits. Don't confuse it with the word limit that we've done already, okay? It means a different thing here. What does it mean to have limits here? Well, it means exactly the same thing as before. So, for example, if this has an answer of, let's just call it capital F, when you put these limits in, all it means is you put B into your answer, you put A into your answer, and you subtract.
And you're going to use this with the graph, right?
Yes, and we're going to tie that into the graph now in a moment.
Because I can't do the graph really precisely.
Yes. Here, for our first example, what this means is you integrate, so this will be x squared over 2, but then what happens? The 2's cancel. And the 0, 1 just means put in 0 and put in 1.
Can you just put a line after it? Without the brackets?
We should really use brackets. We should. Yes? Another question? No?
Is there a bracket? You just draw that.
Yeah, no, that's okay. That's okay. I guess I'm putting the brackets here to really emphasize that it's everything in here that gets the 1. So everything gets the 1, and then everything gets the 0, and you subtract. Now you might say, Stephen, you forgot the C here when you integrate. Well, in fact, it is okay not to put the C here, because if you had the C, all that would happen is you'd get 1 plus C minus 0 plus C. So now it doesn't actually matter about the C anymore, because they'll always cancel when you minus them. Okay? So for this lesson, it is not necessary to write the C. So when you have limits, it's not necessary to write the C. So let's have a look at a couple of more examples. So that's kind of your first example, just to get you started. Okay. So let's take, I don't know, this is like 1D as an example. Minus 1 to 4. No, sorry, this is minus 3 to 1. (16x plus 6). So that would be 16x squared over 2 plus 6x with the 1 and the minus 3. That would be 8x squared plus 6x with the 1 and the minus 3, which would be, so if I put in the 1 first, I get 8 plus 6. And then if I put the minus 3 in next, I get 72 minus 18. So I have here 14 minus 72, 62, 54. Is that right? So then that would be 40 minus 40? I don't know. Is that right? I don't know anymore. 1, yeah, it is. Yes. Because you weren't listening to me. Yeah. I don't need to, because if I put the plus C here and here, it always cancels. So it's not necessary. It is unnecessary. That's what I was trying to say here. Doesn't change the answer. So really, there isn't anything new here except for putting in two numbers. But just a couple of small things to say here about this. Can I scroll down? Yes. So, firstly, Suppose we had minus AB fx dx. That would be minus f integrated b minus fa. Okay, but that is fa minus fb, which is actually the same thing as this, beta a fx dx. That's not a useful result so much, but it's important that you see it. That if you had a minus in the front, you could get rid of the minus if you needed to into a plus, and then the price that you pay is you swap these. Or if you swap these, you need to change the sign. Listen, please. In which one? Oh, here? Oh, yes, and that's fine too. Yes. This is just a property I'm showing you, yes. No, it's fine. You could do this like normal, and then, like you said, multiply your final answer by minus 1. It's absolutely fine. Okay. What's that? No, not quite that. I'm just saying, if for whatever reason you need to swap your limits, when you swap, the price you pay is you put a minus in the front.
The answer means the same.
But the answer means the same and will be the same. Just like with the log, okay? Remember when you swap the argument and the base, what's the price you pay? You have to then invert the fraction.
Yeah.
So I'm just saying, if you ever need to swap the limits, the price that you pay is you change the sign in the front. Okay? Now, tell me, what does derivative mean? On the graph, what does derivative represent?
Slope.
Slope of what?
Of
The slope of the tangent line to the graph. Okay. Joshua, I feel like I'm losing you. Stay focused now, or I'll move you as well. I'm not saying you're not focused, I just feel like it might be approaching not being focused. Still with me?
He's on the edge.
He's on the edge, yeah. He's about to tip over, and the only space I have left, right here. And I'd rather keep the space free. Okay, so we're going to have a look now at what does this mean. We know that derivative means slope of tangent. This here has a meaning as well, which you're going to look at. So you have to pay close attention here. It can be a bit complicated. Can I scroll down now? Yep. Okay, so let's start off by drawing our function. So here we have our y-axis, and then here we have our x-axis. Okay, and then let's imagine now we have some kind of curve here. No, don't make it so silly. We'll just make it a quadratic looking curve. Okay, I'm going to mark this point here off as x and draw a straight line up, and then mark this point here off as x plus h and draw a straight line up. Now this is fx. I'm going to make up a function, and I'm going to call this function ax. And what it is, it's the area from 0 to x. So in other words, for example, here, ax would be all of this area. That's what ax represents. So likewise, what would ax plus h represent? Well, that would be the area from 0 to x plus h, which would be this area. So in green, that's that area, and then in blue is the other one. Okay. So if I have area ax plus h minus area of x, what's that one on the graph? It's the green area minus the blue area,
X plus X.
which is, it's just going to be this area in red. Yes? That's the area in red. No, because AH would be the area from 0 to H, which would be quite small. So it doesn't have anything like that. It's not A anything. I mean, it might turn out to be AH. I don't think it will, though. But anyways, we'll just go ahead with this. AX plus H minus AX, that's this red area here. Now, if I was to draw a straight line here and break it up into a triangle and a rectangle, I could get roughly what the area is. I mean, it's not going to be exact because it's not a straight line here, is it? It's a curve. But roughly it's a straight line. So it's the base. How big is the base here? How big is this base? Anyone can see? H. It's the base by the height. Now the height is, if this is x, then this here is fx. You know, x, then this is fx. Okay. Now, triangle. Well, triangle we know it's half the base by the height. Now, we'll zoom out again actually. What is the height of this triangle here? F x plus h, very good, minus f of x. Because this height here is f x plus h. So if I subtract them, I've got the height of the triangle. F x plus h minus f of x. Okay, I'm going to divide both sides here by h. So what happens is these two go. And I'm left with this. A x plus h minus ax all over h is roughly equal to fx plus a half fx plus h minus a half fx. Now you see that on the right you have two things that go together. It's a x plus h minus ax all over h roughly equal a half fx, because this one can go together with that one, plus a half fx plus h. Okay. Now what I'll do is I'll make h go to 0. So if h goes to 0, this would be a half x plus a half x, which equals just fx. But who can tell me what this here would be when h goes to 0? What is that? No. No.
AX.
No.
Minus
What? What? Say again, no, go ahead. What?
You said
Infinite? No.
1.
Top one. Nobody's, has anyone tried 0 yet?
Yeah, I did.
No, it's not 0.
Very true.
Think back to your lesson about first principles. This on the left is the formula for derivative, isn't it?
Yes.
Remember fx plus h minus fx all over h. That's derivative of f when h goes to 0. So on the left, this becomes derivative of a. So you get this result, that derivative of my area function is equal to fx. Okay. So how do I cancel a derivative? Yes. So if I put now an antiderivative on both sides, I get this. So I get ax equals this. Now, nearly finished, not quite yet. What does ax represent? That was the area from 0 to x. There is a small problem on the right though. Let's imagine we integrated this into capital F. There's a plus c here, isn't there? But if I go back to my well, I'll go draw a new graph here. I don't know what this c is. It's a problem. But let's pretend, or not let's pretend, but let's see what happens if I want the area between A and B. The area between A and B, let's just call it, I'll just call it area A to B. That would be the same thing as the area to B minus the area to A. So you can see there that would be FB plus C minus FA plus C. So in fact, not knowing the C's here, we don't know the C's is not a problem because they're going to cancel. This is going to be FB minus FA. So you end up saying that the area from A to B is FB minus FA. But let's remind ourselves of what that means. That is integrate from A to B, fx dx. So we end up with the result, the area from A to B, is equal to that. So that's the important result here. A result that some people probably have seen before. Yes, because I think Yusuf, you were talking about area being used here, and some people have seen this before, okay? So anyways, now you know the reason why it represents area. Sorry. You have now seen the reason why it represents area.
Do we have to do all of this just to no? Good.
That's fine. That's why I changed my verb from no to see. Yes.
It's smart.
Yes. I felt it was important that you see it because a lot of people just know that integration represents area, but maybe they haven't seen the reason why it's the area. So that's the reason there.
So A is the derivative from F.
Say again?
A is the derivative that came from F.
Now A and B are given. Yeah. What I suppose I'm trying to get to is if you were to calculate something like this, 0 to 1 x squared dx, what you're actually calculating is the area from 0 to 1 on the graph. Yeah. So if this is our graph, and this is 0, and this is 1, what answer you get here, it represents the area there. And in fact, we're going to do that in the second class today. For the first class, I just want you to know what you're calculating. All these indefinite integrals, you can use them for calculating area. But more about that in the second class. But it's important to know that result. Now, there's another type of question to look at. So the the last thing to see in this is quite a short lesson. Is it always possible to calculate the indefinite integral? So what was my first example I did? I think it was, well, maybe you can tell me, was it 0 to 1, 2x? That was my first example.
Yeah.
And there's no problem there. Okay, so let's have a look at an example here. Can I scroll down now? Mm-hmm. Yeah. Okay. Let's say we had something like this. Let's say we had something like this. Minus 1 to 1, 1 over x dx, as an example. This equals, what's the antiderivative here? Log x, yeah. Now straight away I hope you see that there's a problem here. It's log 1 minus log minus 1, which is no good. So in fact, in this case, you cannot calculate it. Okay, you can't calculate it. But the problem is this. Yeah, because you have log minus 1. The problem here is this. It's not great that the only time you figure out you can't calculate is when you get to the end, when you try to calculate it. So what I'm going to show you now is there a way to check if you can calculate it from the start? Because if there is, you should do it, and if there's not, then you shouldn't do it. Okay? And what you need to do for these is you look, so let's pretend we start the question again. Okay, so start again. Minus 1 to 1, 1 over x dx. Right. Can I use any value for x here? Can I use any number for x? If I had 1 over x, can I always calculate 1 over x? Except for 0. So here you say x does not equal 0. And then what you do is you picture minus 1 and 1 on the number line. So there's 0, there's minus 1, and there's 1. And then what you do is you start at minus 1 and you travel to 1 and you ask yourself, do I ever hit any points I cannot use going from minus 1 to 1? So in this case, is that a yes or a no? Yeah, what point do you hit? 0. So this here we cannot solve. So this one here, no answer. Let me give you another example of how to do this here. So let's say I had 2 to minus 1 square root x dx. So firstly, square root x. Can I use any value here for square root x? Can't use negative. So x must be more than or equal to 0. Yes? So here I start at 2. Well, I'm actually going backwards here. I start at 2 and I travel to minus 1. Do I hit any numbers I'm not allowed to use? Yeah, as soon as I go past 0.
Yeah.
So I travel along, and then once I pass 0, I'm into numbers I can't use. So I can tell that this one has no answer. Okay? So this is a way to check if you have an answer or not. Which is, in number 3, I don't want the number answer. In number 3, I just want you to tell me if you can get an answer or not. And there's a name here. If you can get an answer, you call it proper. And if you can't get an answer, you call it improper. So in number 3, I just want to say if it's proper or improper. So have a look at 3a. And just look at it and tell me, is it proper or improper? 3a. What do you think? Look at 3a. Proper or improper? Improper. Exactly. The negative numbers, yeah. What about b? Yeah, well, we have to do a quick check. What value of x can we not use? Minus 2 over 9. We can't use x as minus 2 over 9. I think number 3b is proper. It's proper. What about c? Proper or improper? Proper. D? Proper. E? Proper. F is proper. Okay. And you get the idea. What about Q? What about 3Q? Because it hits 0 between minus 4 and 3. Okay? So this question 3 here is it's really just practicing, checking if it's proper or improper. Okay? Now in the exam, there were 2 questions I skipped from 2013 and 2012. It's these ones I skipped. Not the proper, improper, the calculation. Yeah. So what we'll do is, let me think, I will let you work on these for a few minutes. Then I will do those two questions I skipped, and then we'll look at the next lesson. Okay? Do you remember the section A, there was the derivative question, where you have to calculate the derivative and then put in the number for x. Remember that? And I said you would check your answer on your calculator because there was a derivative one in the top. Now, why does it seem like I forgot this? Anyways, this question usually goes together in section A. So there's usually question 9 is derivative and 10 is this topic, or sometimes the other way around. But it's really, really good in the exam because these questions here could be up to 5 marks. And the derivative question could be up to 5 marks. So you could get up to 10 marks for calculating a derivative or an antiderivative, which isn't so difficult because you get the formula book with the table in it. And you have a table in your notebook as well. So it's a good question in the section A of the exam. It should be a full mark question in section A. It has been on, I think, every section A for the last 7 years. Okay? So there's no reason why you can't get a good grade in practice. Practice. So I'd like you to try for me now. Let's try and do one of each type in number 1. So a linear, a cubic, a quadratic. That would be JKLM. Yeah, JKLM. And then from number 2, number 2 can be UVWXYZ. And I want one with a cos in it as well, so I. So anyways, number 1 is JKLM, and number 2 is UVWXYZ and I. And then for number 3, number 3, just do A, B, C, D, E, F, G, H, I. You don't need, in number 3, you don't necessarily need to write anything down. I just want you to write down. I want you to look at it and write down if it's proper or improper.
I know this one, just do it.
I believe that, Jess. That's fine. Okay, stand with those now for a few minutes, please. If you can tell in your head by just looking at it, you can just write down proper or improper.